And in this question, we'll talk about how we can capture file system changes that we've isolated. This question is titled, how do I capture file system changes that have been isolated? And we're going to talk about overlay file systems. We're going to talk about what they are, what they do, and we're going to show you a really, really cool thing that I do for my own management of my own user software. Let's get started and let's take a look. Let's say that I chose to use a very fancy tool like brep, and I chose to create a tempfs to create a temporary file system that only exists for the duration of that script so that I can have a repeatable, isolatable environment. That's why I love brep. This makes it so easy. And let's say I did that for a complex program that had some really complex configuration and runtime state. Well, every time I relaunch it, it's going to start with the same starting point. So that's a good thing. That's repeatable. But I won't ever be able to capture like the temporary state. And maybe I want to see what it did. Maybe I want to run in an environment and see what artifacts it created. What folders did it create? You ever started a program and it created a bunch of things in your home directory, and you're like, oh, I don't want to use this anymore, and then you have to go and figure out how to delete all those things? That's happened to me multiple times. And unfortunately, some of the stuff in the KDE suite, oh my goodness, the number of directories and files that they create, if you start Evolution or Kmail, oh my goodness, there's so much stuff that's created. And when you don't want to use it anymore, you're just digging around saying, wait, is this still in use? Is this necessary? Do I need this or not? Well, it would be nice for me to be able to run these in isolated environments, but capture what the result of that environment is to see what that looks like. And if you think about it, a file system is kind of like a dictionary in Python. It's a mapping from some location, a file system path, to some object, some data. And you could think a program that we run that interacts with that file system is like something that is setting and retrieving from this dictionary. Well, if I wanted to take my chain map analogy, well, it fits quite nicely because you could think that if I wanted to create an isolated file system, I would just add a layer to this chain map. And if I wanted to look at what had happened to that layer, when I pop that layer off, I'd capture that layer. And so I want this layering idea. I want the ability to start something with not an actual file system, but an actual file system with a synthetic layer on top where that layer captures all the writes. Well, this is actually surprisingly possible to do in user space without special privileges, making use of something called Fuse. Fuse was added to the Linux kernel many, many years ago. And it is the ability for you to mount file systems in user space, meaning you do not have to be the root user in order to create a file system. And you may have used this before. Some things like ejectable media have Fuse file systems that you can use, so you don't have to have root access in order to be able to mount a USB stick. Things like SSHFS is a Fuse file system, so you don't have to sudo SSHFS. You can just do this. Well, it's the ability to actually have user space, user-controlled file systems that you mount. Fuse also gives you the ability to hook into it. It's an API for hooking into all the file system operations so you can customize them. So when you write to a SSHFS file system, it doesn't actually write to disk. It translates that over the network and it writes to the remote machine. There are Fuse file systems for overlay. And there's a couple of these. Some of these that are used by tools like Podman and Docker, and some of these that are not. The two that you might have heard of are Fuse Overlay FS and Union FS. And they both broadly work the same way. You create a mount point, and in that mount point, you start with a real directory, a base directory, and then a layer on top. And you can set those layers to read-only or read-write. And when you write, the writes get caught on the very first read-write layer. Pretty simple. It's all in user space, so you don't need special privileges. You can create these things and unmount these things to your heart's content as easy as can be. Now, it's a little bit tricky in my system here to show you what that looks like to actually Union FS mount. So let's take a look at what might actually happen. Here, I have three directories, a base directory, a changes directory, and a work directory. I am going to Union FS mount. Hopefully I have not already done this. Okay, so let's unmount this. Oh, these physical artifacts, they always bite you. Okay, let's Union FS mount this, and let's go into our work directory. There's a file called ABC in this work directory. What does this contain? Oops. Oh, it contains numbers from 1 to 10. In my work directory, why don't I write to this file? Let's give it the numbers 1 to 20. Okay, let's see what's in this file. Okay, great. Let's see what's in my base directory. There's an ABC file. Let's see what's in that file. Nothing. Well, hold on a second. How is the file empty? Let's see what's in that changes directory. Oh, 1 to 20. Let's create a new file with 1 to 10 called def. Let's see what's in my base directory. Nothing. Let's see what's in my changes directory. Oh, ABC and def. What I've done is I've taken a base directory, I've mapped a changes directory on top, and I have a working directory where I can work. Any changes I make at that working level will hit that changes directory, and they'll get stuck there. New files, new directories, deletion of files, deletion of directories, changing files, or changing directories, and they'll get stuck at that level, and you can visibly see all the deltas at that level. The base directory will be untouched. Well, that's really useful, because what I could do is, for example, start with a base directory that has some known starting setup, always mount a changes directory on top, then run my application. Every time that application closes, I could see what changes it made, and if something went wrong with the configuration option or I wanted to play around, I could just delete that changes directory and pop off that level, or I could keep it. I could merge that back down into my base directory. I do this all the time because I have lots of computers. I can't stop buying computers. I don't know why. I have at least 3 computers on my desk right now, and they are all seamlessly synced. Because part of what I want to do is I want to isolate myself from changes that might happen when, for example, I'm drinking a glass of orange juice and I orange juice my computer and I got to do something in 5 minutes time. Let me just switch to another machine, and I want it to be perfectly synced. But how do you sync something like Firefox or Chrome? I couldn't just copy that back and forth because there's a lot of runtime state. But what I could do is that I could have a base directory, and that base directory contains a known state of my Firefox and Chrome. Every time I launch it, I could launch it with brap with a unionfs directory. All of the runtime changes, all the cache files, and all the things that happen could be caught in that intermediate layer. I don't sync that intermediate layer. I only sync the base layer. The base layer never changes unless I explicitly want it to change. If the problem isn't that I orange juice my computer, but I installed a plugin in Chrome and that wasn't what I wanted to do, or I changed the configuration option, I can't remember what it is, I just nuke the changes layer and I start over from a known state. The idea of isolating your work is not just for deployable work, it's also for keeping your own environment sane. Because if I told you, here is a machine, and it has auto updates, and there's no way to roll back an update, you know exactly what's going to happen. An update's going to come in on Friday at 3 p.m., right in the middle of you doing something really important that you want to get out before the weekend. It's going to break something. You're going to be like, can I roll this back? There's no rollback policy. Now I have to fix this piece of software I wasn't even thinking about, and I was already not sure I'd be able to leave by 5 p.m., and now my entire weekend is ruined. Anytime you rely on the outside world, you are subject to the whims of scheduling of the outside world. When you work in the environment I work in which there is rapid changing requirements and a need to deliver predictably on a schedule, irrespective of what changes, it's all about isolation, and I isolate the core tools and software that I use so that if my Zoom, if my Firefox, if any other desktop application needs to be rewound to a working known state, I can have it rewound to a working known state, but because it writes that unionfs directory, if everything's fine, then it also can accumulate changes because it just launches it within that unionfs every single time. The combination of brap and unionfs gives you the ability to containerize in an ad hoc fashion applications that are running on your system so that you can always roll them back to a known state or sync them between machines. And I tell you what, when one of my computers goes down, I can pick up the next computer and pick up my work with no more than 5 minutes of downtime, and it's exactly the same, literally down to the line-by-line configuration of every piece of software is identical among very different machines, desktops, laptops, servers, and whatnot, because I just kind of CP everything around, but I use this combination of unionfs and brap.